Welcome back to the Transportation Sales Tax Program, also known as Roadwise. I'm Cheryl Harleston, and we have two guests today from MWV Specialty Chemicals. For some of us who've been around for a while, it was Mead Westvaco, but not anymore. It's been rebranded, and wonderful company doing all sorts of interesting things here in this building, in the lab that hopefully you're taking a look at eventually in this segment. But we were talking before we went to the break about the fact that there's all sorts of ingredients involved, aggregates, you heard the word aggregates and things like that are put together. But the thing about this product, Evotherm, is that they add, or an additive is placed into the mix, which then does a couple of things, and those things are what?
Yeah, the additive, which goes into your asphalt pavement at a very, very small loading, at a very small dosage. Percentage-wise, it's 0.5% of the bitumen. It's about 0.02% of the finished pavement. So 0.02% of the finished pavement is the chemical that we make here in Charleston at the refinery across the street that's derived from some byproducts from paper making, from the pine tree principally. That dosage is very low, but what that chemical does is two chief benefits. The first one is it enables the contractor, when he puts it into the bitumen, it enables the contractor to reduce the temperatures at which he makes his paving mixture. And then from that reduced temperature stem many other benefits. A second benefit that chemical, that additive, that's at 0.02% of the finished pavement, by weight of the finished pavement, it's at that dosage, that chemical makes that bitumen stick to the rock for the life of the road.
And how long is that life, though? Is it maintenance
20
is an
years.
issue for people who build roads, like the Transportation Sales Tax Program. So how long do you allow this to remain without it having to be replaced
The
or
engineers
patched, as we saw in the old days?
It's a good question. It's called design life. Engineers like to shoot for a 20-year design life. And that design life can be achieved. It's like anything. The quality of the finished product is directly proportional to the amount of money you put into the finished product. So your home, my home, a road could last forever if you wanted to without the first bit of maintenance on it, conceivably, but you'd have to spend a lot of money for it. And so that doesn't work out in the grand scheme of things. It's better to build the road and allow it to be maintained periodically, like you paint your house periodically. We maintain the roads periodically. So the typical design life is 20 years. And
we're going to be talking about how this product is being used around the world and is being created right here in our backyard in Charleston County. But before we go to that, I'm wondering, what have been why have others seen the need to do this, to maintain the roads for a longer period of time? I'm sure they wanted it. They, meaning various municipalities and governmental agencies and other organizations that are responsible for our road system. But we haven't done it. When did you come up with this product? And are you ahead of the curve or what?
Yeah, I would say well ahead of the curve in terms of the warm mix arena. Warm mix came into existence probably about 10 years ago. I would say warm mix technologies now and warm mix construction are really the norm, the standard, versus 10 years ago when hot mix was the standard. And I think we shared earlier, but maybe we didn't, the genesis behind warm mix was really about worker exposure and environmental benefits. And some of those benefits, some of those exposure issues turned out to be confounded, but at that point the whole warm mix perception came into play. The public, the agencies and the contractors kind of gravitated and grabbed onto the concept and the idea that if we make this hot mix warm, we can do a lot of different things. We could save on fuel, we can reduce worker exposure issues, we can take out ingredients that we would have normally put in. What makes Evotherm so unique, it enables the contractor to take out a number of different components and replace them with one. Namely, in South Carolina, we use lime primarily as our adhesion promoter. It allows contractors to remove that. in a case like a porous pavement application, which was recently completed here in Charleston County, they used a polymer modified asphalt, which has styrene, butadiene, styrene in it. We enabled the contractor to remove that, which is very costly to the agency.
Boy, that's a big word.
It was. I got it
And so
out.
what's that mean?
So that means we are replacing more expensive components with a product that's in there at
0.02%.
0.02% of the finished mix, and we're actually creating a road that will last longer than how it was conventionally done.
I'm a taxpayer. You're a taxpayer. A lot of taxpayers watching us, hopefully. And we have to say to the public, we're using your dollars to benefit this community in a way that is truly responsible.
Yeah.
And a giant step, it sounds like, was this Evotherm. And I'm wondering, for those who are the environmentalists listening to us and watching us today, certainly we're working with the money. It's fewer dollars, hopefully over a long run. But for the environmentalists, what will this do? Because we watched this pervious material take on water and disappear. Where does it go, and is that an environmental concern that we ought to have?
No, it shouldn't be a concern to anybody. And when you're looking at pervious pavements or even impermeable pavements, what historically was the conventional type of pavement built around the world until recently, until the development of permeable or pervious pavements, the engineer, the road construction engineer, should design the road so that the water is managed, it flows off of the road, and is collected in some sort of water management facility, a ditch in the simplest sense, or a sewer system if you want to get more complicated. But the water that runs off the road has been demonstrated to be clean. There are no components that are coming out of the road. So the water that's rushing through a porous pavement is perfectly okay for the environment. It's the same rainwater that hit the pavement that's running into the sewer or to the ditch alongside of the road.
Now, we've talked about this on other programs because we've had some of your fellow employees on who talked about the fact that the layers that are involved are also very important. Very quickly, what kind of layers are they, and where does that water go?
Okay. Yeah. So if you start with what you see is the black top, so that's about 2 inches of this pervious pavement, and by pervious pavement I mean it has a void structure of about 20%. So the void structure is what gives it that ability to drain the water, the openness.
Yeah.
So if you look at the mix, it looks like popcorn.
Exactly, for me anyway.
Yep. And so from there, from the popcorn, it actually drains into what they call the recharge bed, which is another, it could be anywhere from 6 to 8 inches deep of just standard stone, standard aggregate. And that kind of acts as a buffer, retention, to capture the rainwater. And then from there, it goes actually into the aquifer, the soil. And the way that these products work, the way the pervious pavement works, is it has to have a soil that drains. So all we're doing is we're giving it a direct route into the soil, and then from the soil it actually disperses into the existing environment.
Okay, and that's part of the question. Where does the water go? And apparently it just sits there in these layers, or doesn't it?
No.
Sit there, and then suppose you move or remove the entire road at some point, just dug it all up. What would I find underneath?
The same thing you put there, simply.
Undisturbed.
Undisturbed, yeah. As long as the thing that disturbs our roads, the thing that causes earthquakes notwithstanding, the thing that disturbs our roads are the traffic loads that the roads have to support. And over time, you can have translational motion in a pavement due to traffic load. The most common one we see is rutting, where you see a pavement's got ruts, and that rut usually extends down. But what's underneath that pavement will always be underneath that pavement. You can go in some roads, probably around Charleston as well, but elsewhere around the world, you can dig a yard down and still find the roads because they're often just built up.
I'm glad you mentioned around the world, because we're going to be talking about how this product, this wonderful new invention, if you will, is being used around the world, coming straight from Charleston County, South Carolina.